Kia ora Year 13. This is part of question 1 from last year's probability distributions exam paper. Usually when I do these exam questions I have a clip from the PDF of the exam paper, but I'm having trouble with the iPad, so I've just typed it out myself. It's just about word for word, but you might like to go download the exam paper to check that for yourself. What we're working with here is a triangular distribution. We're given some information in the start of the question, and then we've got 2 probability questions that we're going to do. The first is an achieved one, and the second's a merit question. So we're told that the amount of water used when taking a shower can be modelled by a random variable that takes on values between 20 litres and 200 litres, and the most likely amount is 50 litres. So straight away I know that that's a triangular distribution because I've been given the minimum, 20, the maximum, 200, and the mode, which is 50. And we call those A, B and C. So we're going to work with the triangular distribution, but I'm not going to use the formula to find the height. I'm going to do it using similar triangles, and if you're in my class, that's the way that you'll be used to anyway. You're really welcome to do it with the formula, and you should go and check that you get the same answers, but I just don't want the video to get too long. Okay, so what I want you to do now is to pause and try and work the questions through on your own and see how you get on. Okay, let's start by drawing our graph. I know you're going to do yours using a snapper card or a ruler or something nice, so don't do what I'm doing here. You probably just broke the first rule of teaching, but that's okay. So there's 20, and there's 200, and there's 50. So that's x, which is the number of litres of water used in a shower. Up here, we've got f of x. So f of x is the height of the function. And the first thing we do with a triangular problem is we work out what I call the peak height. So at the top of the triangle, at this vertex here, how high are we? Now, the way to think about that is to say that the area under that curve, under the triangle, is equal to 1 because it's a probability distribution. And we know that the area of the triangle is half the base times the height. So we can work that out to be a half of 180. Okay, so the base is not 200, it's 200 minus 20 times h. Rearranging that, we get h is equal to 2 over 180. And again, if you've done these in class with me, you'll know that the peak height always works out to be 2 divided by the base. Okay, but these steps show you why. So the height is 2 over the base, which is equal to 1 over 90. Now because that's a really, really small number, I don't want to round that. So I'm going to put it on here as just 1/90th. If you do feel compelled to turn that into a decimal, just leave it like this. Either dot, dot, dot. Oh no, what's happened? Okay, 1, 1, 1, 1, 1. Going on forever, or you could write it as 0.01 recurring if you like recurring decimals, but you're better off to just leave it as a fraction. So that's the first step done, and now we've got to look at what were the 2 questions we're asked to find. Well, the first one is a really easy one, which is just to find the probability that, or to find an estimate of the probability that fewer than 50 litres of water are used in a shower. So we're now going to find the area of this triangle, but I'm going to do it on a new slide. So the probability that x is less than or equal to 50 is equal to half times the base times the height. Think about that triangle. My base is going to be 30. My height is 1 over 90. So my probability is a half times 30 times 1/90th, which is equal to, what have I got there? 1/6. Or as a recurring decimal I get 0.16 recurring. If I'm rounding it to 4 decimal places, which is what I usually recommend that you do, it's that, but we were asked to find the percentage of showers that use 50 litres or less of water. So we want to turn that into a percentage, right? So it's about, what are we going to say, 16.7% of showers use 50 litres or less. Now notice I've been pretty loose about whether I've said less than 50 litres or 50 litres or less. That's because we've got a continuous distribution, so there's no difference between those two statements, right? Because litres of water is a continuous variable. So that's the first part done. In the next question we have to do the probability that more than 40 litres are used. Okay, so we want to find the probability that x is greater than 40, and we're going to draw a picture to see the easiest way to proceed, because it will depend on where 40 is in that triangle. So here's 20, and here's 50. So let's mark 40 on there. Now, it's going to be a pain to do that probability directly, because we'd have to do that trapezium, and then we'd have to do that triangle. So it's not hard, it's just extra work. Instead, we can say that that's equal to 1 minus the probability of less than or equal to 40 litres being used. Again, I could have written just I could have written that there and it would make no difference to my answer, right? Because I've got a continuous distribution. So that's equal to this green triangle here. That's the probability of using less than 40 litres. So we're now going to find the green triangle. To do that, we have to figure out f of 40. Now, you can do that using your formula, or you can do it the similar triangles way. So we're starting here, and we know that if we go along to the 40 point, we've gone 20 units along this way. If we were going the whole way to 50, that would be 30 units. So we've gone 2/3 of the way along towards 50. Because the green triangle is similar to the big triangle, we know that f of 40 is going to be 2/3 of the way up to the peak height. So it's going to be 2/3 of 1/90th. Right? So that's the similar triangle way to find the height. Right? I'll just go over that again in case you haven't seen it before. So just forward if you have, because for lots of you this will be feeling really easy. So we're starting here, and we're asking what proportion of the way to the top are we going? So when we go from 20 to 40, we've gone along 20. When we go the whole way, we've gone along 30. So we've gone 2/3 or 20/30ths of the way to the top. So that means we must have gone a similar proportion of the way up to the peak height. So 2/3 of 1/90th. Okay, so that we can write that as a fraction. We get 2 over 270. So that's f of 40. Now, if you work through that big ugly formula, you'll get to exactly the same point, right? But you just have to watch your a, b, and your c, and your x. And so I would far rather do it this way. So f of 40 is 2 over 270. So the probability that x is less than or equal to 40 is equal to half times the base times the height, which is going to be a half times 20, right? The base is from 20 to 40, so it's that bit there, times 2 over 270. So it's going to be quite a little number. It's going to be 2 over 27, which works out to be 0.07407. But that's not the end of the question, because we're trying to find the probability that x is greater than 40. So we want 1 minus that number. I'm just going to finish that off on the last slide. Alright, so hopefully you'll see that having good clear working is going to help you not muck up your answers. So now we have 1 minus 0.07407, which is approximately 0.92 something. Let's have a wee look. Should be able to do that, shouldn't I? 0.9260, or maybe it's 0.9259. Okay, so that is a really pretty straightforward merit question. You do need to be very confident with the triangular distribution because it is a really useful one both for the exam but also actually for real life. Okay, it's good because it fits situations where you don't have a symmetric distribution and you just know 3 little bits of information. Okay, thanks for watching, and let me know what you want me to do next.